Hello students, welcome to my channel Gyan Meter. Today's topic of discussion is data representation and I'll be using computer science with Python. So this is the book by Sumita Arora. I think most of the class 11s are using this book. This is going to be a series of videos. So today we'll talk about how to convert decimal to binary. The next videos will talk about how to convert it to octal, then hexadecimal. So watch the entire series to understand and get a grasp of the concept. And I have made it very simple. I have also told you certain tips and tricks so that you don't fumble during the examination hall. So I hope you enjoy the video, and I have also given you certain problems at the end of the video. So stick to the video and let's just jump right into it. The topic I've selected today is number system and converting them into various data types. But let's understand what are the data representation that we find. We start off with binary, then followed by octal numbers, then we have decimal number which we use in our day-to-day mathematics, and then we have hexadecimal numbers. Okay, so what are the numbers, which are the numbers that comprise this data? For binary, 0 and 1 are the numbers that comprise the binary data set. For octal, it starts from 0 up till 7. It comprises of 8 digits. And for decimal, as we know, 0 to 9. For hexadecimal, we can understand that there will be 15 digits. So we start with the decimal part of it, 0 to 9, followed by the other numbers which we represent as A, B, C, D up till F. So over here, the numbers 10, 11 up till 15 represent our A to F numbers. Now the conversion part of it is could be confusing when you try to convert from decimal to other numbers or other numbers to decimal. So there's a trick into how to keep in mind like what is the method we should use. So keep your eyes on the letter D. D means decimal, and if you want to convert any decimal numbers to any of the following binary or octal or hexadecimal, so what we need to do is D stands for divide. Okay, so we have to divide when we have to use the method divide to get hold of the conversion numbers. That's the trick behind it. So we'll show you in the next part as to how to do it. Now I'll be showing you certain examples where you have to convert decimal form into its respective binary form. So over here we have taken 43 and you have to convert it to its binary form. The tens and twos that I have written here is the base. So that is how you make people understand that 43 is represented in a decimal form. So when you have to convert to any of the form, you have to divide with the conversion base. So in this case, we need a binary form. So we are taking 2. We divide it. So 2 into 21 is 42. We get a remainder 1. Then again divided. 2 tens are 20. Again a remainder 1. Then followed by 2 fives are 10. Remainder 0. Then 2 twos are 4. Remainder 1. Then 2 ones are 2. Remainder 0, and we have to place the last number 1 which is not divisible, so we just place the number 1. So this is how you will see in your books. This is how they represent, and we have to write the number from bottom to top approach. So the arrow helps you to understand. You have to write the number 1 0 1 0 1 1, and that's your answer in the binary form. So 43 it into any binary form is that answer. Next, we have another example. You have to convert 200 to its binary form. So similar process, but over here what I have done, I have placed the remainder just next to it. It becomes easier. In the book you might see it the way I did the first question. So 225, again 0 remainder, 2 12s will be 24. So 1 remainder, we write it, 2 6 12, 0, 2 3s are 6, again 0, then we'll have 2 1s are 2, we have remainder, so we write 1, and lastly we just put the 1 next to it, and again the
bottom to top approach, and we write the number as 11000100 base 2. So 200 is represented in binary form as this number. So this is how you do it. Take a moment to understand this process. Pause the video and practice it yourself, and you might understand what is the rule. So this is where the division comes. So you're dividing with the converting base and you're getting the answer. In the previous examples, we dealt with numbers which did not have a decimal point. So what if we have numbers which include those decimal points? How to solve them? So it's very easy. You divide the number into two parts. The first part is 200. So you do the normal thing that we did in the previous examples. Basically, you divide with the conversion base and you write the remainders next to it. And what you have to do is, next we have to do is the bottom to top approach, and you get the converted form of it. So I'm doing this now. We write the remainder 1, put the last number 1, and this is, we are done with the first half. The next half, we write the number 0.375, and then what we do is multiply with the conversion base. So we divided the first half, now we are multiplying with the second half. So this is going to come as 0.75. Now we write the number before the decimal part. Over here in this case it's 0. Now we take the remaining part, that is 0.75, and again we complete the process. Again multiply by 2, 1.5. We take the numerical part of it, 1. We take the part after the decimal, that's 0.5, multiply with 2 and we get 1. We take the number, the numerical part, that is 1, and we have our answer. So our goal is to multiply as long as we can nullify the decimal, that is we get 0 as the decimal part, and we write the process from top to bottom. So first one was bottom to top, that is 11000100 point, then top to bottom, that is 011 base 2. So this is your answer, converted answer in binary form for 200.375. Like in the previous example, you won't be lucky always and get decimal as 0, because there might be some decimal numbers which will lead to recurring numbers and you might not get a similar result. So what you should do that time, so in this case we again divided the number and we are doing the first half. It's very simple, you're dividing it, that's what we do. And 2 2s are 4, 0, and 2 1s are 2. So we'll write the remainder 0 and then 1, and we'll do the process, that is bottom to top. First half done and dusted. Now 0.21. So if you can now get it that you won't get a 0 in this case, so you put the number 0, get the decimal part, again multiply with 2, 0.84, again that part is 0, remaining part 0.84 into 2, you get 1.68, you get 1, but you still don't get a 0, so you again multiply 0.68 with 2, you will be getting 1.36, again 1, still no luck. So 0.36 into 2, we get 0.72, and we continue. So it depends on your school also, like they might say that you can do up till 5 decimal places if you don't get a 0, or 6, that totally depends upon your institution. So in this case I did 6 of them. And then we are doing the top to bottom approach for the decimal part of it, and now we just have to write the answer, that is 1001110 point, now top to bottom 001101 to the base 2, and that's your answer for the binary form. So these are the problems that you need to solve. I have kept it for the end. The 3 questions talks about the concept I have been talking in my lecture.
Do state your answers in the comment section below, and I'll be revealing them in my next video. Hope you guys enjoy it. Please don't forget to like, share and comment, and let me know if there's something that you guys want to learn.